All right, let's quickly go over last night's homework. So velocity, 3t squared minus 24t plus 36, quadratic. V of 3 is negative 9. So if the velocity is negative, then that particle is decreasing. Particle is at rest. That occurs when the velocity is equal to 0. So we set our velocity equal to 0. Divide everything by 3, factor, find our roots. So we get that the particle is at rest at 2 and 6. In order to determine when the particle is moving forwards or backwards, we would look at the velocity in terms of a number line. So that's what I did over here. So I said, okay, here's velocity. We know that velocity is at 0, at 2 and 6. We also know that velocity at 3 was negative. So what that tells me is that the position function is increasing, then decreasing, then increasing again. So that means 2 is a max and 6 is a min on my particle motion function. That also tells me in terms of it asked forwards and backwards. It's moving forward when the object is positive and backwards when the object is negative. So to answer that question, it is moving forwards from 0 to 2 and 6 to infinity. To find the total distance traveled, it's not just simply finding two numbers and adding them together, or just finding the distance at 0 and the distance at 8. So the particle at 0 would be at 0, and the particle at 8 is at 32. But you could see that the total distance was 64. And the reason for that is because the particle is moving forward from 0 to 2. So we need to find the absolute value or displacement from 0 to 2. Then the particle is moving backwards from 2 to 6. So you need to find the particle's position at 6. And then you need to find its new position at 8. So it's fairly easy to see that the particle moved in a positive direction from 0 to 2, 32 units, and it moved in the positive direction from 6 to 8, 32 units. So that's where the 64 units, and this would be moving forward. But then you also need to take into account that the particle from 6 to 2 moved 32 units backwards. So it moved 64 units forwards and 32 more units backwards. So it moved a total of 96 units. So it's kind of like the absolute values of all the positions. So S of 2 minus S of 0. And then S of 6 minus S of 2. And then S of 8 minus S of 6. And then what you do is find the absolute value of all those displacements and sum them together. So that's where the 32, 32, and 32 all came from. Acceleration. Acceleration is the derivative of velocity. So the acceleration is 6t minus 24. The acceleration at 3 seconds is -6. And then when we graph each of these functions from 0 to 8, we can see that position is in fact increasing, maxes out at 2, decreases to 6, and then increases again from 6 on. So forwards, backwards, forwards. Here's the velocity. So we can see that the velocity is at its min when acceleration is at 0. Velocity is at 0 when position is at an extrema. When the position is forward, velocity is positive. When position is backward, velocity is negative. And position is forward when, once again, the velocity is positive. And then the very last question down at the bottom, when is the particle speeding up? So an object is speeding up when acceleration and velocity are both positive, or when acceleration and velocity are both negative. So we know that velocity has key points at 2 and 6. So we know that at 2, it's positive, negative, positive. Acceleration, we can see here in the graph, acceleration is 0 at 4. So we're going to add a new piece to my line graph. We're going to add in a 4. So what that means is that, again, it's negative here. The acceleration from 0 to 4 is negative. And then positive from 4 on. So from 0 to 2, they have opposing signs. From 2 to 4, they're both negative. From 4 to 6, they're opposing. And from 6 on, they're both positive. So what that means is that the object is speeding up from 0 or from 2 to 4 and from 6 to infinity, and that it is slowing down from 0 to 2 and 4 to 6. So speeding up is when the signs are the same. Slowing down is when velocity and acceleration have opposite signs. So hopefully all of that makes sense to you and that helps you understand the lesson a little. Alright, so let's do the particle motion for the trig derivative now. So velocity equals the derivative of the particle's motion. So derivative of cosine is negative sine pi t over 4. And I apologize because this was a chain rule, and that's what we're going to learn next. So you actually need to multiply and add in to all of your notes the derivative of the inside, which is pi fourths. So I am sure that you don't have that, so you need to put that on there as well. So then velocity at 3 seconds, that's v of 3. So you have negative pi fourths sine 4 pi, sine 3 pi over 4. So this is why I said it is so important to remember or recall your trig derivatives. So 3 pi fourths is a trig value. It is in quadrant 2. The sign in quadrant 2 is positive. So 3 pi fourths is root 2 over 2. So you get negative pi fourths times root 2 over 2, which is like negative root 2 pi all over 8. When is the particle at rest? The particle is at rest when velocity is equal to 0. So you divide both sides, the negative pi fourths will cancel out. So then you get sine of pi fourths t has to equal 0. So you kind of take the inverse sine of that, and the inverse sine of 0 is 0. So then it becomes, okay, when does 0 equal pi fourths t? So that's at t equals 0. But we also know that sine is 0 at pi. So you need to also consider when pi equals pi fourths t. So that is at t equals 4. And then that would continue to repeat. So it would happen again at 2 pi, which would be when t is equal to 8. So hopefully you're starting to recognize this pattern, that the particle is going to be at rest every 4 seconds. So then when is the particle moving forward? When is the particle moving backwards? So what we want to do is look at this sign of the trig function for this problem. So you'd pick a value in between 0 and 4, maybe like 2. So that's negative pi fourths times the sine of, we pick 2, so that would be 2 pi fourths, or pi halves. Well, the sine of pi halves is negative 1, or sorry, positive 1, but then it's times a negative pi fourths, so it's negative. Then you do the reverse, pick a number between 4 and 8, like 6, so that would give you 6 pi fourths. Well, 6 pi fourths is like 3 pi halves. The sign at 3 pi halves is in fact negative, so a negative times a negative would give you a positive. And again, because the unit circle is just that, a circle, these signs would continue to alter back and forth. So the particle is moving forward from 4 to 8, and then it would be backwards 8 to 12, and then 12 to 16, then backwards 16 to 20, and then again 20 to 24, and so on and so forth.
Find the total distance traveled during 8 seconds. Well, we know that whatever it moves forward, it's moving backwards the same. So we need to find the position at 0, the position at 4, and its position at 8. And then find the absolute value of the change from 4 to 0 and add it to the absolute value of the change from 8 to 4. So at 0, cosine of 0 is 1. At 4, that would be the cosine of pi. So the cosine of pi is -1. At 8, well, that would give you 8 divided by 4, which is 2, which is 2 pi. Cosine of 2 pi is back at 1. So we have that this is equal to the absolute value of -1 minus 1 plus the absolute value of 1 minus a -1. So -1 minus 1 is 2. And 1 minus a -1 is also 2. So 2 forwards and 2 backwards means it's moved 4 units. Acceleration is derivative of velocity. So again, you might be off a little because you didn't have that pi-4ths. So it would be negative pi-4ths. Derivative sign is cosine pi-4ths t, once again, times a pi-4ths. So you're probably missing that negative pi squared 16 cosine pi-4ths t. So you're just probably missing that constant. So you're just going to have to multiply and add it back in. So you get a of 3 equals pi squared 16, and this is negative still, cosine 3 pi-4ths. Well, cosine of 3 pi-4ths is negative √2/2. So you get a positive √2 pi squared 32. So to graph these, I'm going to start by graphing velocity in green. So 1, 2, 3, 4, 0. 1, 2, 3, 4, 0. Velocity started at 0. The velocity is negative from 0 to 4. And we said that the velocity at 2 was equal to negative pi-4ths. So plotting the points on velocity at 0 is easy. And then it's also nice because we know that the amplitude of cosine is 1. So I know I'm going to go up basically by, because of the pi-4ths, I'm going to go up by 4ths. So that gets me to 1 over here, and then this would be down the same. So I know that cosine is going to be at 1 at 0. I know that cosine is at -1 at 4, and that cosine is back at 1 at 8. So that kind of gives me an idea of where my graph is going. It's going to be at 0, at 2, and 6, because if you think about plugging in a 2 here, that gives you pi halves. We know that the cosine of pi halves is 0. and then it would come back down. So there's my cosine. Remember that the derivative is velocity, which is sine, and we know that the sine is basically the normal sine function, but that it has an amplitude of negative pi fourths. So what that means is that the sine isn't going to be higher or lower than that pi fourths value. So if I were to graph that, I know that it's kind of really flattened out. That amplitude basically compressed my graph. So upon graphing this, I know that I do not want my graph to be beyond those two mins and maxes. So once again, if cosine is 0, that's kind of like its point of inflection as well. So that's going to act as the extrema for my sine function. And we know that it's negative from 0 to 4, and then positive, and then back to negative. The acceleration function is shrunk even smaller than both of those. But what we can do is use that chart from the other day to figure out acceleration. So if this graph is concave down, then the acceleration is negative. If the graph is concave up, then the acceleration is positive. So my acceleration should look something like this. And then acceleration also has properties based on velocity. So if velocity is decreasing, acceleration is negative. Velocity is increasing, acceleration is positive. So that was also how I knew that this was negative, positive, negative. And then the last part talks about speeding up and slowing down again. So it's much easier to almost look at our graph. So acceleration and velocity are both negative till 2. So that means if they're both negative from 0 to 2, it is speeding up. And then at 2, acceleration is positive, but velocity is negative. So from 2 to 4, it's slowing down. And then from 4 to 6, they're both positive, so it's speeding up. And then at 6 to 8, they're opposing. So velocity is positive, acceleration is negative. So slowing down. And then at 8, they're both negative again. And they would both be negative till 10. And then you can see this is moving by increments of 2. 0 to 2, speeding up. 2 to 4, slowing down. 4 to 6, speeding up. 6 to 8, slowing down. 8 to 10, speeding up. 10 to 12, slowing down. 12 to 14, speeding up. 14 to 16, slowing down, and so on and so forth. And again, that comes from that cyclical pattern of a cosine and sine function. A little more. The next thing I want to talk about for today is derivatives in economics. Engineers use the term velocity and acceleration to talk about physical movement. In econ, We use terms like marginal to describe rates of change in production and cost. The word marginal is the calculus word for derivative in economics. So the cost of production is typically a C of X product. And then marginal cost would be the derivative of that cost function, or C prime. And so cost of production is obviously the cost represented to produce a number of units. And then the marginal cost would be the rate of change of that cost with respect to the level of production. So suppose we're given a cost function and we are producing X radiators from 8 to 10 are produced, and we have a R of X. The R of X represents revenue. So profit is cost and revenue kind of together. So if you think about the cost to produce, that's how much you lose. The revenue is how much you make. So your profit is your revenue minus your cost. If your profit's negative, then you need to make changes. So currently the shop is producing 10 radiators per day. We want to determine if that is productive. So marginal cost would be C prime of X. Marginal revenue would be R prime of X. And then, like I said, profit is cost minus revenue, or revenue minus cost. It really doesn't matter. So the derivative of that is here. And then if you think about maximizing that, our maximum profit would occur when our derivative is 0. So that would give me the max